Good morning, everyone. I'm Xavier Marchand. I'm a field application engineer with Interface Concept. Interface Concept designs and manufactures VPX boards, such as switches, single board computers, and FPGA boards. Today, my presentation is about connecting with VITA 66.5. I'm going to try to answer a few questions. What is VITA 66.5? How does it compare to the existing optical interconnect standards? How can it help with innovation in VPX systems and within the SOSA ecosystem? How can it answer the current market requirements? In the embedded world, VPX systems are becoming more sophisticated. In the past, separate functions tended to be implemented in different products. Today, the trend is to combine these functions into large products. For example, a typical system today can contain several single-board computers, multiple payload or FPGA boards for signal processing, switches, timing cards, power supply cards. These large systems drive three needs: the needs for more bandwidth in the backplane, the need to easily swap boards in and out, and the need for flexible and scalable VPX backplane connectors. Let's start with backplane bandwidth. Since we have more boards in these large systems, more communication takes place through the backplane. Two other factors stressing the backplane bandwidth are the increase of the processing speed on processor boards, as well as the increase of processing speeds on processor boards. And let's move. These large systems also need to be reconfigured with different sets of boards depending on the mission. These large systems also need to have a variety of interfaces. They need to have optical interfaces on the backplane. They need to have RF interfaces. They need to have VPX interfaces. These interfaces should be scalable to support the required throughput, and they need to be flexible to support the required features. So what are typical communication technologies used across VPX backplanes? VPX systems today mainly use Ethernet and PCI Express. Ethernet and PCI Express answer various interconnection needs. For example, SOSA defines Ethernet as the protocol to use for data and control planes, and PCI Express as the protocol to use for the expansion plane. So if we focus on the backplane bandwidth for now, how can we increase the communication speed in the backplane? Both Ethernet and PCI Express use bidirectional channels called lanes to transfer data. One solution would be to increase the lane speed. For example, for Ethernet today, it's pretty common to find lanes that can carry a 10 gigabit Ethernet signal. We could enhance these lanes to carry a 25 gig Ethernet signal instead. While doable, going from 10 gig lanes to 25 gig lanes requires a significant amount of changes in the system. We would need a new backplane. We would need different VPX boards supporting the higher speed signals. The cost impact would be quite significant. So an alternative solution is to look at increasing the lane density in the backplane. And we will see how VITA 66.5 can help. So what is VITA 66.5? VITA 66.5 is a standard developed by the VITA Standard Organization. It is in a draft stage right now. It is compatible with VITA 46 VPX. It implements a blind mate connection with fixed contact on the VPX board and a spring-loaded contact on the backplane. 66.5 is not the first optical interconnect standard. It's the 5th variant of optical interconnect standard for VPX. 66.0 is the standard common to all the variants, which defines the mechanical mounting interfaces. .1 is the full-width MT variant. .2 is the ARINC 801 variant. .3 is the expanded beam variant, and .4 is the half-width variant. So let's focus a little bit more on these legacy 66.x variants to better understand how they compare to 66.5. Each of these connector solutions contains two sides. There's the VPX card, shown here on top, and there's the VPX backplane side, shown here at the bottom. An interesting way to compare these solutions is to look at their size, the width they occupy on the VPX backplane, and the number of lanes these connector solutions can support. So here in the picture on the right, we're seeing that the VITA 66.3, 0.2, and 0.1 connectors have the same width as a VITA 46.0 connector. They are full-width connectors. By contrast, in the picture on the left, we're seeing a 66.4 connector, which is half the width of a VITA 46.0 connector. This slide also compares the number of lanes of these different connectors at the bottom. And what we can see is that a VITA 46.0 connector supports 16 lanes, whereas a 66.3 connector only supports 2 lanes, .2 connectors, also 2 lanes, .1 connectors, 24 lanes. And on the left, at the bottom left, we can see that a 66.4 connector supports 12 lanes in a half-width connector. However, if we were to instantiate 2 of these connectors side by side to occupy the same width as a full-width VITA 46.0 connector, we would have 24 lanes. So it's interesting to compare the size and the number of lanes of these connectors to have a better understanding of their relative lane densities. So now that we've taken a look at the legacy 66.x connectors, let's look at 66.5. This is an example of a VITA 66.5 stile connector based on Reflex Photonics Light Connects 12 TRX solution. This solution integrates 24 fibers or 12 lanes. A lane, consists of 2 fibers. So that's why we have 12 lanes. This is actually a pretty compact solution because the optical transceiver is integrated inside the plug-in module shown on top. And each of those lanes is capable of carrying 10 gig Ethernet signal. So the stile A is only one of the styles offered through 66.5. There are actually 3 styles, A, B, and C, as well as a variety of customization options, which depend on the backplane aperture, the number of empty ferrules that you're trying to support, and whether RF connectors need to be present. This slide shows the VITA 66.5 solutions offered through Reflex Photonics. At the top of the slide, in green, we can see the different backplane apertures that can be supported. And we can see, for example, that with a VITA 66.4 backplane aperture, a VITA 66.5 stile A solution is suitable. And for example, with a VITA 67.3D backplane aperture, a stile C or a stile B solution is also suitable. What we can also see here on this slide is that one of these solutions in the middle here, the stile B, integrates not only 1 empty ferrules, but 2 empty ferrules. What's also interesting here is the stile CRF shown on the right, which integrates on the same connector both optical and RF links. So these are just some examples of the variety of options available through VITA 66.5. So now that we have taken a look at the benefits, now that we've taken a look at the basic features of 66.5, let's spend some time going over some of the benefits. So one of the first benefits is the lane density that is achievable through 66.5. This slide is a comparison of different connector solutions. This comparison is normalized to a full-width VITA 46.0 connector. So for half-width connector solutions, like 66.4 and 66.5, we've instantiated two connectors side by side to occupy the same width as a full-width connector. So what we can see here, for example, is that a VITA 46.0 connector integrates 16 lanes. And by contrast, a 66.5 style B connector at the bottom integrates 48 lanes. So arguably, 66.5 has one of the best densities on the VBX backplane. Another benefit is the simplified board replacement or two-level maintenance. By moving the optical interfaces from the front panel to the backplane and using blind made connection, boards can be easily replaced and quickly replaced. We don't need to disconnect optical cables any longer. Boards can be replaced in the field, even in a harsh, cold, and dark environment where gloves may be required. So here we're showing, in the picture on the right, the example of an interface concept Comet 4082E switch, implementing a 66.5 plug-in module from Reflex Photonics. This solution supports 12 optical lanes, each capable of carrying a 10 gigabit Ethernet signal. Another benefit is shown here. It's the flexible backplane connections. We are looking here at the backplane side of the same interface concept switch that we were looking at in the previous slide. On the backplane side, it is easy to use an optical cable that will separate, as needed, the lanes for board-to-board connections and to connect to a system I/O port. Here in the picture, we are looking at the example where the 24 fibers are split into two groups of 12 fibers, terminated by MTP-MPO connectors. Other fan-out solutions are possible. We could also split the 24 fibers into three groups of 8. Another benefit that I mentioned earlier, but I wanted to have a special slide for it, is the possibility to integrate on the same connector the optical and the RF connectors, which was not possible with the older standards. So here we are showing the Reflex Photonics on the right, 66.5 style CRF connector. Another benefit is the ability to achieve high-density PCB. And it starts with the fact that the optical transceiver is integrated inside the plug-in module. This allows to optimize the PCB area and to achieve high-density VPX boards, such as this Kintex UltraScale FPGA board. Finally, I wanted to mention one last benefit is the fact that it is reasonably easy to customize a board to adapt to different backplane apertures. This is based on the fact that the 66.4 and the 67.3D apertures can be matched with style A and style C transceiver modules that are pin compatible, and that not only pin compatible but also use the same optical transceiver. The only differences to switch between one solution or the other is we need to change the interposer between the optical transceiver and the PCB, and we need to use a different alignment feature, which is either positioned on top of the optical transceiver or below the optical transceiver. So now that we've taken a look at the benefits of 66.5, let's take a look at the opportunities. SOSA defines, as Mark was talking about earlier, SOSA defines a number of VPX slot profiles. Several of those slot profiles present opportunities for VITA 66.5. So for example, if we look at the switch profiles, two of the four switch profiles within SOSA use this 67.3D backplane aperture, which we saw earlier can be matched with a VITA 66.5 style B or C transceiver module. Some other examples of opportunities within SOSA, if we, for example, look at the payload profiles, the 3U payload profiles, here we're looking at two profiles. The one on top has, again, this 67.3D backplane aperture, which can be matched with a single VITA 66.5 plug-in module. But the profile shown at the bottom has a larger aperture, this pattern H aperture, which can be matched with two VITA 66.5 modules used side by side. So in conclusion, we talked about VITA 66.5, which is a new optical interconnect standard. The standard is in draft stage, but offers some promising benefits, such as the ability to increase the lane density on VPX backplanes, the fact that it makes board replacement easier in the field, supports two-level maintenance. VITA 66.5 offers some flexible options in the backplane, and also the ability to combine in the same connector optical and RF connectors. And the fact that it supports high density VPX boards that can be easily customized. So some solutions exist today with this technology, and we can expect more to become available in the near future to meet the needs of the SOSA ecosystem.